Hello and welcome to the Bio360 podcast. This is the second part of my interview with the famous water scientist Roumiana Tsenkova. Hello, Roumiana.
Hi.
Hey.
Hello.
Thank you. Thank you for being here. And we have already doven. Is that the correct past tense of dive?
Yeah, it is yes.
Dove deeply into the topic of water and the interaction with light, infrared light, absorption, partially absorption, and all that. And I want to continue with you and ask you, what have you learned so far about what actually the light reflects or partially absorbs?
What we have learned that this light signature of water can tell us about disease in different systems. So we have diagnosed plant disease, we have diagnosed animal disease, and also this could tell us the cell development stages. So we have been through, once we understood that the water spectrum has the information about biological system, we stepped down a little bit and we started to perturb water or add to water single molecules like very low concentration of heavy metals, because metals do not absorb light in infrared region. So there is no way that you can measure the molecule, the ion, directly, but only as reflected by water. And we were able to make models and measure those very low concentrations, which was unthinkable to be done by spectroscopy until now.
Wow. So sorry to interrupt you there, but you mean
yes.
by photosspectroscopy? I got some
yes.
difficulties
yes.
with that word. You can measure heavy metals in the body?
I cannot. We haven't done the experiment on the body, but in the water. In the water, we can measure very low concentration of heavy metals.
Okay.
Yes.
So, but we have water in the body, so much water in the body. So that would be like.
Okay. Now this is probably another topic that we will talk about. That the water in the body is structured differently when compared to the water that we drink, and the water in the lake and the water in but probably. No, I'm not saying that we cannot measure the heavy metals in the body, because we probably will be able to measure heavy metals in blood, in urine, in the tissue, but we haven't tried yet. So you're absolutely right. Logically, the signature of the heavy metals on the water should be in the body as well.
Okay, because that would be a huge step forward, because we can only measure what comes out of by urine excretion or in the blood, but we don't have really good measurements to go in the cell and see what's going on there. So if you just can use your device, I'm not going to say it again, then that would be awesome. That would be amazing. And what else could you to test by that? I mean, if you could show heavy metals in the tissues, you could probably show everything, right?
Yeah, we have tried. So we can call it aquaphotomic sensor. So it is we avoid the spectrophotometry, but this aquaphotomic sensor. So you can use if you use it, you can. We tried, and we can see a very a consistent difference between people before they start working and after they finish working. So, and also there is a difference between men and women, and the way that they change before and after working. So it is a device that could monitor the status of the body non-invasively, and you can, you acquire this data for seconds, so you can you can measure as many times as you want.
Okay.
So, and you can measure your water with this device also. But this is what we do. We, for example, we publish a paper on diagnosis of pregnancy of panda by analyzing the urine of panda. And panda can get a kid only once a year, so this is very important. They do artificial insemination, and it is important to know when it has to be done. So, and it was amazing how water spectra changes in the same way when the ovulation is present. So this is what also we can do with this.
Okay, so you're measuring the spectrum that is partially absorbed and then reflected by the water, but. So, and you can show disease, you can show maybe certain substances in that water, yes. But how does actually a disease show up in the water? How is that information? Is it information that is passed over to the water? And how is that mechanism?
Okay.
If there's a mechanism, actually,
yes,
that's the right word.
Yes.
That transmission happening?
Yes, it is exactly. The point is to understand the mechanism, and the mechanism is in restructuring of the water molecules connected. Because imagine, so we have to. I think the point is to increase our knowledge about water as not just like a H2O, one water molecule, but a complexity. A system of water molecules that is restructuring, so making different working groups, kind of. So, and this restructuring tells us what is actually like immune system. When we are getting a disease, the immune system starts acting, right? And actually, in beneath it's all water that is restructuring. So. We published recently a paper on so-called resurrection plants, a plant that can survive after 2 years without any water. So you add some water and it gets green again. And we understood how it's happening. It is happening because this plant has the ability to control the water molecular structure, different functional water groups of water molecules that have different, obviously, so something that we still don't know in details, but we are on the way to understand how each of these formations is working and what is the purpose of all these water molecular formations. So the phenomena is within water molecular structuring.
So the water gets molecularly structured by the body it sits in, right?
Yes, exactly.
Okay, even if we don't know the exact mechanism, that's actually what's happening. And so that creates the unique signature, and that's why we can actually show if we're healthy or not, or if we are a cow or not.
Yes, and we can see this restructuring by shedding an infrared light on water. So this light actually is bringing us the knowledge about this exactly structures and functions of those structures.
Okay, interesting. You mentioned earlier that light is also a good conductor. Is there any what is the interaction with the body? Because we're made out of a ton of silicon, and silicon is a good conductor. So could you talk a little bit about electricity, actually?
Very good question. So it stays in my to-do list. Actually, I can only think of silicon is in the water in a cell wall, actually, and the water in the cell wall is very important. And actually, the there is not this. The cell wall is dewater with the lipids and silicon in that, and water is working based on this charge distribution, and silicon I guess is orchestrating and having it. It is also has to do with the coherence of water and setting up the frequency of the vibration frequencies that imitate a kind of the vibrations of silicon. But this is still to be further explored. But the good news is that we can measure it, and with hyperspectral imaging cameras already we can go down to the cells, to a single cell, to the water cell, the cell wall, and in near future we'll be able to exactly pin down the mechanism of this interaction.
Okay, got it. So I heard once we have like around 200 different types of water in the body. How do actually, because you said like the water outside of the body is different than the water inside of the body when we were talking about the heavy metals and everything. So how do actually waters differ in the body? Like in our brain, in our eye, you said 95%, in our gut,
Yes. Imagine all the molecules that we have working now, thanks to this reductionist omics sciences. We know all the proteins, we know all the genes, and we published a paper on DNA, and we found out that actually UV light is distracting DNA through the water, which is next to DNA. So there is a water solvation shell. Water molecules are really aligned next to DNA. And the first thing that UV does is restructuring this water. So it is an example that, you asked me how different is. I don't know if there are 200 or 300, I don't know how many waters are in the body, but they are defined by the molecules that they surround. And also we have intracellular water, which has also different structure. But the water in the cell is like a gel. It does not spill out. So it is not the liquid water that we have that we drink, and it is. It gets all the elements of the cell in one and working machine. And
you can't poke a hole in us and then it's like we're spilling out of water. Like that would be a problem.
Yes, exactly. So, but this is an image how water is different in the body, right?
Yeah. Okay. Yes. So fascinating. So by the surrounding tissue and wherever it is, the water actually is different, as we already like alluded that like the water changes in regards to like everything and every time. So you find different qualities and even different shapes and forms. Okay. Yep. So we were talking about EMF and things like that. Like, how can the water be disturbed? Like, what is actually having a bad effect on the waters in our body?
I will start with the most strongest perturbation to water is temperature.
Okay.
Temperature influences the water, I think, most. It could, and maybe that's why the temperature, we use another word, fever, in our body. Body reacts to different illnesses by temperature, right? Mm-hmm. So, and this is because temperature restructures the water in a way to, we say immune system is fighting the disease, yes. And this is by restructuring the water. So another For example, when you increase the temperature with only 1 degree, for example, all the water molecule that are making hydrogen bonds and are in groups, they start become more free. They can make other conformations easily because they have to fight. They have to work in a different way. They have to restructure. Then another, you can get influenced. Water can get influenced easily by humidity, by the moon phase. We have measured this, and so we're to publish a paper on this. And what is very interesting, different waters react differently to the moon phase, for example. All waters react to the temperature. All waters change with temperature, but the degree of changes is different. So it is very interesting. Of course, different people react to temperature differently. That's logical. And also, of course, we talked about electromagnetic field that can influence the water, and sound. Sound is also a very, we can influence the water with sound in a very light way, sensitive way, I would say. Because, as I said in the beginning, water does not like strong perturbations. I mean, you can, like sugar. You eat lots of sugar, and you just stop. Water stops working. Water changes, and then doesn't move at all. And the same with lots of salt.
Okay. That's very interesting. Let me just quickly say something about that. So. Found that very interesting. So temperature, you said, it's a huge perturbation to or changing mechanism to water. What's actually happening when I go to sauna or taking a cold bath?
What you do, you are making your water more flexible, more reactive. Mm-hmm. So the water in your body is becoming more flexible in terms it can meet and react to any outside perturbation.
When it's exposed to heat, right?
Yes, exactly.
Okay, and when it's exposed to cold?
Well, when it is exposed to cold, you get more energy because the water molecules make hydrogen bonds, and hydrogen bond means energy. So stored energy, like a battery. So you build up your battery in your body. You build up a battery of energy that can be released at any time your body needs them.
Okay, so that may explain why a cold bath you feel so energized after that. And
yes, and when you do both, then you make your water more flexible and more reactive. So it could adapt more adaptive. It could easily adapt to the needs of free water molecules that you get with high temperature, and more energy when you get with low temperature.
Yeah, so that's why I'm loving it so much. And also our mutual friend, which is just sitting next to you, Rasmus Gaub-Berghausen.
Yes, I know.
He is like crazy about the cold water, and he actually swims up to 30 minutes in the most in the coldest lakes he can find. And
yes.
So
but we have to know that water does not like extremes, and so water is maybe the best system that shows us how important is the balance. I mean, it's not good to go in one or the other end. So it is very intelligent to keep the balance between the two.
Okay, but inside our body, it never really goes. I mean, if we go in the sauna or in the cold bath, the changes of the water in our body are not so dramatic.
Yeah, thanks God, yes.
Yeah, otherwise,
What is very intelligent, yes. What is very intelligent.
So it's a little bit of exercise, going a little bit up, going a little bit down, but actually we kind of have a core temperature.
Yeah, but you said a very important thing. Exercise is very, very important. And because exercise is like, imagine a lake with a still water that water doesn't move. You get lots of microorganisms there, lots of pathogens, and it is a sick water. So, and the same with our body. So if water doesn't move, it's not able to work, and we get sick. So we have to move the water in our bodies, and we have to exercise, and we have to work and move and make our brain work also.
Yeah.
Yes.
Yeah. Sure. Yeah, that's an important point. I'm always always pointing to that. You also mentioned sound, and that's why I mentioned Rasmus, who also made very kindly the connection between you and me, and because he's working with sound and he has created his system, which is called Sound of Soul. Just wanted quickly to mention where you can make your heart sing and then listen to the tunes of your heart, and so that is very interesting, because then also that sound will affect all the water in our bodies, right? How beautiful is that?
Exactly.
Yeah.
So this is what we have done an experiment together, and we could see beautiful differences between the signature of the body before and after the listening to this sound, and it kind of having a uniform influence to people after listening to the sound. So we have to understand what exactly is happening. So, and this is what I hope we can do in the future.
All right. Talking about the future, I like to interrupt the episode here at this point. I think a last time, and continue with you in the next. Thank you for being here today, Roumiana.
Thank you very much. Thank you too.